Right. Yeah, as I already said, there's only one example today, just to kind of show you something else that can happen. It kind of did happen on your worksheet for yesterday because I kind of wanted to see what you would do. It happened on number 2. That basically really, had you not done number 1, you would have had to have done integration by parts twice. That can happen, but you kind of had the answer sitting right up there. I set you up pretty nice for that one. But this one here, this will be the first time we looked at trig. And let's face it, if you take the derivative or antiderivative of any trig, does it really ever go away? It just turns into some other trig, right? That's basically what happens. And so we know sine's really not going to go anywhere, but we also see an x squared there. Does that have potential of going away? Yeah, it does. Now, don't necessarily write down what I'm going to show you next, but just kind of follow my thought process here. Some people are tempted to do this. Because they say, well, there's an x right there. Can't I just substitute that in? But basically, once you substitute it in, you're going to have a sine of du. Do we know how to do sine of respect to u? Not really. You want it to be sine of u. That you can do. Or various other things like that. So that substitution's not necessarily going to work. Okay, now if that was sine of, say, x to the third, then we could do substitution because u could be x to the third. Du would work out fairly well for us. So here, basically, we know sine's not going to go anywhere. But x squared could, correct? X squared could, if I kept taking the derivative, could go away. So that would lead me to believe if x squared could go away, should I make x squared u or make it dv? Okay, if I make it dv, what do I have to do to x squared? I have to take the antiderivative, which actually makes it bigger. So let's put u over there. And dv right here, which is, now remember what I told you yesterday, if you're going to use integration by parts, which I have to here because substitution's not going to work, you have to replace everything. Because that's what integration by parts tells you to do. But in integration by parts, you need u, you need du, and you need v. So we better go get those. I've got u, so let's go get du. Is 2x dx. Does this 2x dx actually have to be in the problem if you're doing integration by parts? No, it doesn't have to be in the problem. The only stuff that has to be in the problem is your u and your dv. And I need v. Well, we know the derivative, remember, this is how I remember it. The derivative of sine is just cosine, right? So the antiderivative is negative cosine. Any questions on that so far? All right, now remember, this is kind of how I do it. You need to go u times v. So is it okay if I put negative x squared cosine of x? Is everybody all right with that? Minus, because it comes in the integration by parts formula, the integration of those two times each other. You can do whatever you want. You can take that 2 out. I'm just going to write it here, and then you tell me what you want to do. It's a negative 2x cosine of x dx. So here's where I'll listen to what you want to do, because it's going to work either way. It doesn't matter which way you want to do it. You can take that negative 2 out and put it out front, or you can leave it in there. It's whatever you want to. Or you can just take the negative out if you just want to take that out. It's your choice. You can take the negative and the 2 if you want, or just the negative, or just the 2. Unfortunately, you can't take an x out. You can't take a cosine of x out. So what would you prefer to do? Negative 2? All right. So what that means is that, agreed, it turns into a plus, and then there's a 2 sitting out front. Our goal is hopefully, once we get to here, it's something we can take the antiderivative of without too much difficulty. Unfortunately, substitution doesn't work there. And our only choice then is integration by parts. Now, people in the past have then said, well, if this first integration by parts didn't work, let's switch what we did. Let's make dv and u the opposite things. Well, then you're just going to kind of get right back to where you started, so that might not be the best plan. So let's make u x, dv then is cosine of x dx. But in integration by parts, you need du, which is 1 dx. And v is, well, the derivative of cosine is negative sine, correct? So the antiderivative is sine. And once you have to do integration by parts more than once, that's when you're going to like this whole box idea of box the part of the answer that you already know, so you don't lose it. Because the plus 2 is actually going to be out front of this other antiderivative. Yeah, you're going to have to distribute the 2 through or leave it out front, whichever way you want to do it. Yep. Because this is times right there. Okay. So I'm running out of room. Or underline it if you want. Yeah, I wouldn't box it because then you're going to think it's just part of your, you know, just plus 2 is part of your answer when it's actually 2 times stuff. So this becomes x times that. So here we go. X sine of x. So you might want to write the 2 like this maybe. Maybe that'll help. I don't know. Remember it. Minus the integral of sine x dx. So far, let's write what we've got so far. We've got a negative x squared cosine of x, excuse me, plus 2x sine of x. That's what we've got so far. Here's your 2x sine of x that I just wrote. Have we finally gotten that antiderivative to something we actually know and don't have to do substitution or by parts or anything like that? Yeah, we've gotten it to something that it's pretty straightforward. In fact, we've already kind of done that on this problem. But we have to take the antiderivative of sine. Remember, the derivative is just cosine, so the antiderivative is negative cosine. So who thinks they can tell me what I should write as the last part of the answer? Be careful. A lot of signs, a lot of distributing, a lot of things that you could do wrong. Taylor? None of those are right, unfortunately. They're all very close. Yes. It is plus 2 cosine of x. Because here's your 2. This becomes a negative from right here, and this itself is negative cosine of x, so it becomes a plus. The 2 gets distributed, so plus 2 cosine of x plus a constant. So you can see, just imagine if this hadn't turned to a plus 2 here, and you had to distribute the negative. Well, that would have just thrown another negative in the problem. I know, just looking at it right now, it's very hard to believe that what I have circled in green, if you were to take the derivative, you would get x squared sine of x. It's very hard to see. Okay, a lot of stuff would cancel off. Yeah, taking that derivative by the definition would be all sorts of fun. There'd be, what, 5x plus delta x's in there? 3 of them in the angle. That'd be awesome. So do you see that you can do it more than once? The hardest part is keeping it organized. Do you have any questions on any of the steps that I took in that problem? And let's not forget, integration by parts is the last resort. Look for it maybe just on your sheet. Maybe it's just on there, and do that. Maybe it's one we just know. And then your second choice would be, obviously, substitution, if that's going to work. Third choice, last resort at this point, is integration by parts. Taylor? Yep, exactly. Yep. And you decided to take it out. At least taking the negative out at that step is a great idea. You could have left the 2 in there if you thought that would be a problem. Because some people look ahead at this step and they say, you know what, if I leave the 2 in there, I still have to do integration by parts again. If I leave the 2 in there, I don't have to worry about distributing it. So that's a choice you have to make. Or if you look in there and you say, oh, this is going to be the last step, you can maybe take the 2 out and not worry about it. But I would definitely get that negative out of there because that's just too many negatives flying around. Because you realize negatives would have ended up down here too. And there would have been negatives everywhere. And so I would definitely take the negative out if you have that option. But the 2, that's really your personal preference. Anything else?